So now we're going to discuss our clinical UPS. For these questions, given set A, a set of numbers, then determine the set of Z. Z is integers. Integers can be positive integers, 0, or negative integers. So soalan ni memerlukan nombor bulat yang positif, nombor bulat yang negatif ataupun nombor kosong. So berdasarkan jawapan kita, this is integers, this is integers. So this is integers, this is also positive integers. For square root 16, it is equals to 4. Yes, this is integers. For 5 square, it will equals to 25. So it also are integers, positive integers. Meanwhile, for 1 over 9, so it will be equals to 1 over 3 is not integers because integers adalah nombor bulat. So that's why our answer will go for 1 and 2. Next, which of the following is irrational? Irrational adalah nombor decimal, non-terminating decimal. Or it won't have any pattern, it will have non-pattern. The decimal will come out randomly, so it will not have any pattern, and also it will not terminating. So for square root 8, so we can check with calculator. Square root 8. You want to see the decimal, you can notice that our decimal here, it is going non-repeating and then non-terminating. So this will be our answer. So actually, it still have its decimal after that, but our calculator only can show us until this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they show us 11 figures only. So for 2i, it is not real. This is not under real number. This is complex number. So meanwhile, 31 over 20. So this is rational number. Rational number means the number can be expressed in pecahan ataupun if you find 31 over 20, you'll notice that the decimal at the back here is stop terminating. It just come to 1.55 only. So this is rational number. So this is also rational number. Irrational number will be equal to A. Then we're going to see this question where we need this interval x less than 4. Not included. So empty circle less than 4, we draw it to the left hand side. This will be our number line for the first interval here. So the next interval will be -1 until 5, and then you have to be careful here. Our value of x here is integers. So again, integers is nombor bulat. So it will not involving any decimal. So from -1, 0, 1, 2, 3, 4, and 5. So just now, less than 4. So for this interval, -1 included. Nombor bulat, integers, -1 included. So 0, 1, 2, 3, 4, until 5. But 5 is not included. So this number 5 is not included. So this will be our interval -1 until 5, where this number all are integers. So nombor bulat itu saja, tak ada terlibat nombor decimal dia. So we are going to do intersection. Intersection adalah tempat nak bersilang. So inilah nombor dia, -1, 0, 1, 2, 3, 4. Bukan, sebab ini ada, this is not include, this one is include. So 4 is not included. So therefore, we only involving answer 1, -1, 0, 1, 2, 3. So it's not an interval. So that's why our answer will be this, number by number. Then we're going to look at this question, find value a, b, so that this operation will give you 9i. So this is a complex number. So we can see that complex number, we can compare where real part. So you at the right hand side here doesn't have any real part. So 2 plus a plus 2b equals to 0. Meanwhile, imaginary part, a minus b will be 9. So equation 1, equation 2. So we can do this simultaneous equation by eliminating equation 1 minus equation 2, so that a and a can be eliminated. 2 minus negative b give us 3b. Then 0 minus negative 9, we give us negative. 0 minus 9 gives us negative 9. Therefore, b equals to negative 3. Then we substitute back into equation 2. A minus 3 equals to 9. So a will be so here will be positive 3. Move to the right hand side, it will be minus 3. It gives us 6. So here will be our answer. Then we go for this. Simplify this division of complex number. When we have division of complex number, we need to time with its conjugate. So the conjugate of this denominator, it will be 1 plus I. Therefore, complex number times with its conjugate, it will give you a squared plus b squared, so which is 1 plus 1. So for numerator, we will expand as usual. It will be 2 plus 2i. So this will be 2 plus 2i over 2. So simplify, the real part equals to 1, imaginary part equals to 1 also. So here will be our answer. So for this question, it is impossible you can get wrong, because we can check using any calculation involving number. We can check using calculator. We can set up our mode to be complex number. Then we can just plug in our value, 2 over 1 minus I, where I is this purple color, shift ENG. So here we can double check our answer. After that, continue for this. Since I already set my calculator in complex number, so for finding modulus and argument, I also can using calculator to check my answer. So you're going to find it from shift 2, where is complex number function here. Is for new calculator, you just press option. Everything is in your option. So I want modulus and argument. So I want R and data. So number 3. So what is your complex number? It will be negative 3 times I. So I put at the back. So automatic we can read modulus is 3. So 90 degree. Okay, so bear in mind when we're doing complex number, we cannot use degree. We must use radian. So automatic it will change to radian, negative 1 over 2 pi. So here will be our answer. So that is using calculator to check answer. So if I want to perform in calculation modulus of complex number, it will be square root of a squared plus b squared. So for this complex number, you don't have any real part. So 0 square plus imaginary part. So this is our negative 3 square. If you read, we have to rearrange complex number equals to negative 3i. So from here we simplify negative 3 square and square root, it will give you 3 only. And then when we want to find argument, we draw out our Argand diagram. Real number 0, imaginary a is 0, b is negative cert 3. So our position of our complex number is at here. So what's your argument? What's your data? The opening angle from here, it will be 90 degrees. So 90 degrees in radian, it should be pi over 2. And then it is in opposite direction from quadrant 4. So therefore it will give you negative. Then find x for this equation. In this first equation, where we can notice that this is 6 over 2x equals to 5. Okay, so we identify the indices, and indices here operation is plus, so we cannot simplify to be a single indices. Therefore, we only can put in let m equals to 2x. So m plus 6 over m equals to 5. We're going to multiply m so that we can get a quadratic. So 5m multiply m become 5 multiply m become 5m. Move to the left hand side, negative. Then we factorize. Then m equals to 2, m equals to 3. Substitute back m is 2 to the power of x. So this power x equals to 1. Meanwhile, for this side, when you want to find x, we log base 2 to the 3. Then notice that our answer is in the base 10. So we change to the base 10. Log base 10 for 3, then log base 10 for 2. So next question, rationalize the denominator. So rationalize the denominator means simplify our denominator here for this fraction. Okay, so we can multiply because you can see our third number is already in conjugate. So 1a minus b times a plus b. For third number, it will be a squared minus b squared. So it will be 1 minus 2. This is a minus b, a plus b. Then for denominator here, so 1 minus 2, it will give you negative 1. For numerator, we expand 5x plus 5x sub 2, then minus 2x plus 2x sub 2. So 5x and minus 2x, it gives us 3x. Then 5x sub 2 plus 2x sub 2, it gives us 7x sub 2 divided by negative 1. So it gives us negative 3x, negative 7x sub 2. So here will be our answer. Find the value of x for this log. So simplify it. So first, we can see that this log base 5, another log also base 5. I can move it to the left hand side so that log minus log, we can simplify it to be a single log, which is the item that log carry here will be divided. Then we can unlog. So it will be 5 to the power of 1. Then we can simplify our x. So here will be our 5x. Collect back. So minus x. Minus 5x, we get x equals to 5. So answer is 5 only. Alright, so for this, so what is your x? So actually, what is your x? We can just log 12 over 10 to the 5. So the base of indices become the base of log. So we notice that we don't have any base of log 12 over 10. So all of this is in the base of 10. So therefore, we simplify. Base 10 of 5 divided by base 10 of new base here is, then we can simplify again. Log 10 5 is log 5. Then when we have item is divide, it will be in the log of operation minus log 10 10. Then we can still can be simplified where 12, when we want to involve in the number 2 and 3, it will be 4 times 3. So here will be 2 squared to get 4 times 3. So times 3 will be log 3. So log plus log, the item will be multiplied. So 4 times 3 to get 12. That log 10 10 will equals to 1. So finally, the power of 2 we can simplify. So here will be our answer. So actually, in other way, we can check by using calculator one by one. So since what the unit is log 12 over 10 for 5, it gives you 8.827. So you can press calculator for every answer here, which can fulfill your answer. This is log, let's say option 1, log 5, and then negative 2, log 2 plus log 3 minus 1. Yeah, so this is different. So this is not. So you can double check here. Log 5 2 log 2 plus log 3 minus 1. Yes, this is our answer. Okay, so without doing this, our calculator can do any calculation using value. Then find the value of x for the following equation. So for the answer, for the x value to be the solution of this third equation, actually we can just come to the last part where this is a solution for third. So we can check whether left hand side equals to the right hand side. So you can use calculator here. We can plug in our third alpha x plus 1. So this is my left hand side. I'll calculate for left hand side first. Okay, so calculate for what kind of answer we have solution. X is 0, so answer is 1. So again, I calculate for 1. The answer is 2. So this 0 we already have. So I want to test for negative 1. Calculate for negative 1. The left hand side gives you 0. What else? Okay, so this has been done. When x is 0, left hand side is 1. When x is 1, left hand side is 2. Then I proceed to right hand side. 1 minus third alpha x. Then calculate. For calculate x 0, it is 1. So it is 1. Okay, so x equals to 0 is a solution. X equals to 0 is a solution. Then continue for x equals to 1. Calculate x for 1. Notice that our right hand side answer here gives us 0, so this is not the solution. So this is not the solution. Automatically, these two options will be eliminated. So lastly, we want to test here where x is -1, make error. So means this is not exist. Therefore, our final answer is this. So this is the way of or the technique of solving objective questions. To check whether the answer is a solution for yours. So same as here. So if you want to calculate one by one, of course also can. We go back to our basic concept. When we have both side modulus, we're going to square both sides. We have both sides square root, we're going to square both sides. So here we have x plus 1 equals to 1 minus surd x. Then we notice that we still have a surd there, so therefore we're going to square both sides again to remove the surd. So here we have x squared plus 2x plus 1. Here we'll have 1, and then alright, so before I square both sides, we can simplify first so that our answer will be more easier. When we have 1/3, we can move it to the left hand side. So others, move it to the right hand side. 1 minus 1, cancel off. Then square both sides. It will give you x equals to x squared. So it's a quadratic factorize where x minus 1. So x is 0, x is 1. Then you're going to check left hand side, right hand side. So the procedure will repeat back like whatever I done just now. So for modulus equation, ask you to solve. Actually, you can also check this is a solution. Is it the x is a solution for this modulus? Alright. Using calculator, modulus, shift, absolute. We type in 2 alpha x minus 3. This is our left hand side. We can check, we calculate when x equals to 1. Left hand side 1. Okay, then we calculate for x equals to -1. Our left hand side is answer 5. So we still have a number. Calculate for x -7/3. Give us 23/3. So here 23/3. And lastly 7/3. 5/3. Alright, then we check right hand side. Right hand side is 4 minus x. 4 minus alpha x. Calculate. For x equals to 1. Answer is 3. Okay, so this out already. Then calculate for -1. Answer is 5. So right hand side is 5. So right hand side is 5. So we are going to consider these two options. So calculate for -7/3. 19/3. Okay, so this answer is out already. Lastly, 7/3. 5/3, yes. So left hand side equals to right hand side. So this is the answer. If by subjectively we want to calculate one by one, then we'll have to do definition for modulus. Buka modulus tu, satu belah positif, lagi satu belah negatif. Masukkan negatif. So kumpulkan x, here will be our 3x plus 3, 7. So x equals to 7/3. So this side minus x. So this one -1. Then for sure, for these two answer, you need to check your answer, left hand side, right hand side, is it same or not? So like what I have done just now, what's your left hand side and right hand side? So negative, like what I have done just now, just repeat the same thing. So both x value can be the solution. So next, inequalities. So our inequalities here, we have two inequalities. We have to rewrite it. So one is 5 less than x minus 4. So, and when we separate these two inequalities in one sentence to become two sentences, it will be using definition and. Okay, then we simplify x. Move x to the left hand side, then 5 to the right hand side. So when you divide by x, negative, you need to change sign, become positive 9. So meanwhile here, we simplify, plus 5 minus 5x. So negative 2x, move to the right hand side, plus 3x. Then 5 plus 4, 9. So x is less than 3. So we are going the next step, intersection this interval, intersect with this interval. 3, 9, less than 3. Another interval, more than 9. Intersection. You don't have any intersection, so that's why the answer will be no solution. Okay, next, this will be our rational inequalities. So rational inequalities, everything move to the left hand side, let it 0. So we can see clearly this is negative region. When we our rational already done, we're going to solve it by positive number line. Let numerator pengangka positif, penyebut positif. So penyebut tak boleh equal 0. X greater than -3. So then we can draw our positive number line involving value -3 and 0. So equal more than that. So this region positive, positive, negative. So for 0 not included, empty circle, positive, negative, negative. Conclusion here is positive, negative, positive. What we need here is negative region. So this is a negative region that we want, where -3 is included, 0 is not included. Okay, so here will be our option. So you can notice that this is our answer, yeah? Absolute inequalities. Alright, so we come to absolute inequalities when you want to define the modulus, when you want to open the modulus. So inequalities bigger than, so bigger bola, bola. So bigger than, we use definition or. So buka modulus, definasi or. So lagi sebelah, masukkan negatif kosong. So negatif kosong, kosong lah. Tukar sign, masukkan negatif kosong. Sini. Okay, so untuk sini kita ringkaskan 3x more than -2x more than -2/3. For this side, x is less than -2/3. -2/3. More than that. Okay. Then another one less than that. Or union. When you have definition or union. Union. So it will be every answer except not including -2/3. So therefore union, you're going to combine. So negative infinity up to -2/3, -2/3, continue to infinity. Then we go for this. They say this is the first three term in your geometry, and then determine your W. When we say geometry means they were having the properties of common ratio. Term yang belakang bahagi term yang pertama, iaitu common ratio ni mesti boleh sama dengan term yang ketiga bahagi dengan term yang kedua. So simplify this, we doing cross multiplication. Then we simplify, expand this quadratic, expand this square, and we rearrange for, and then okay, and then we try to factorize. What's the answer? So we can use calculator. Number 5. Number 5, quadratic, 4, negative 12, and 9. 3 over 2. 3 over 2. And then given that n term is 3n minus 18, find the first term and common difference. So first term a will be t1. So put in our n as 1. So a will be 15. So automatic these two options eliminate, negative 15. So these two options automatic eliminate. This is not correct. Automatic we can get this already. So there is less than 1 minute you can done this. So we can continue if you want to know how to find common difference. Common difference we need T2 minus T1. Common difference is arithmetic, so we use minus. T2 we will substitute 2 into n. So actually just now we get the answer, but we want to continue for the concept. We want to see here is common difference. So 3 times 2 minus 18. So a1 is negative 15. So we just simplify here. Three. Yes. Alright. Then find the number of terms in this geometry sequence. So we want to know this is term ke berapa. Geometry sequence. For the first term, a is 2. Common ratio 6 over 2 is 3. So term yang ke berapa iaitu 39366. Formula for geometry and term a are n minus 1, where a is 2, r is 3. So we simplify these indices, where we can simplify this number first. So let these indices to be 3 to the power of 3, 3 to the power of n minus 1, then 39366 divided by 2. You want n minus 1, we can log 3 to the answer. So n minus 1 equals to 9, so n equals to 10. So for this sequence, which of the following are true statement for this sequence? This is arithmetic. Is it arithmetic? Then we have to see 2 over 9 minus 1 over 3, negative 1 over 9. So this is T2 minus T1 is negative 1 over 9. We have to continue check. How about T3 minus T2? Negative 2 over 27 is not arithmetic. It is not arithmetic. So it will be geometry. Is it geometry? We have to check. If geometry, T2 over T1. 2 over 9 divided by 1 over 3. 2 over 3. How about check the third term with the second term? 4 over 27 divided by 2 over 9. So seems like this is geometry. And then what is your S1? S1 will be equals to sum of the first term. Sum of the first term will be equals back to the T1. So T1 will be your first term, 1 over 3, yes. So answer will be 2 and 3 is the true statement. They are true statements. So last, this one, find the fourth term. So formula, fourth term, TR plus 1 equals to NR, A n minus R, B power of R. So this is our binomial expansion type 1, where power is 6, A is 1. You can see power is 6 positive integers. It will be type 1. B is negative x. So we substitute inside here. We want fourth term. Fourth term means R plus 1 is 4. So R will be equals to 3. Substitute everything, where n is 6, R is 3, A is 1, then 6 minus 3, then B is negative x, R is power of 3. So how you going to press your calculator, figure out all this number? 6C3 times 1, power anything is 1. Then don't forget here got a coefficient of negative 1. Going to power 3. So it will be negative 20x cubed. So answer is in option 1. Then state the range of this x where this expansion is valid. So try to rewrite this in the power form. It will be square root means power to 1 over 2. Inside here 1 minus 3 power negative 1 means 1 over 3x. So this will be looking at the power of 1 over 2. This is our type number 2, where everything must be start with 1. Yes. So the star here will be negative 1 over 3x. So to find validity, it will be modulus star less than 1. So the things that you want to expand here is modulus negative 1 over 3x less than 1. So how to solve this? We can separate the coefficient modulus negative 1 over 3. The coefficient here, modulus negative 1 over 3, will become positive answer. Then we simplify 3, move to the right hand side. Then we open the modulus here. It will be less than 3, more than negative 3. So here we'll have our option 3. Alright, so that's all. Good luck for your UPS.